Graham walks 8 blocks from his home to the library. He always walks 4 blocks to the east. Here we go. North, south, east, west. 4 blocks to the east and 4 blocks south. If I draw a picture of this, okay, and that means he's going from his home. His home would be here, the library would be down there. So one possibility that he could take is go 4 to the east and 4 south and get from his house to the library. That would be one path. Okay? Can you see that this would be a different path? Yes? He could also go like this. We want to count them all. We're at 3. Did I miss any? Oh, okay, you ready? Could do this one. Keep counting. How about that one? Have I counted that one? I know I haven't counted that one. That one I haven't counted. I haven't counted this. Or this one. What else haven't I counted? Oh, can you see yourself getting lost trying to count them all, doing it this way? Did I get them all when I was drawing them, or did I miss something? Be hard to tell. Now, how do we set this up and figure this out? So I'm going to show you 2 different strategies for setting it up and figuring it out. One of them says, well, how could I represent this pathway? What did he do? He went east, then east, then east, then east, and then south and south and south and south. Right? Ooh. I think this is the best way to get home. Like that. Why? It's easy. Oh. So bad. So bad. But what do we have is an identical objects, because going east, you have to go east 4 times somewhere in there, and you have to go south 4 times somewhere in there. If you think, how many different ways that can I arrange this? Well, if I write out S, 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 E, 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 S, E, what would that draw on here? South, 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 east, 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 south, east. And every time I rearrange those letters into a unique word, I get a different path. But if I would just switch 2 identical objects around, it wouldn't actually switch the path. So if I can represent it as 4 E's and 4 S's, then I can count it as an identical objects question. 8 factorial over 4 factorial, 4 factorial. Now another way that we could look at this is start just by counting it slowly. And something interesting happens when you count it slowly. If the library happened to be right there, would you agree there's only one pathway he could get there? Now we're also assuming that Graham is not stupid. He knows how to get to the library. What are paths that we didn't get, that we didn't count? We didn't count this path. Oh, I see the library. No. Oh, no. Oh, right? Graham hopefully has lived here long enough, right? So that, when parents tell their kids to walk home from school, it's not like, oh, Took me 8 hours to walk home. So like I saw it, and then I don't know why, but I turned right. And I took another road. And I kept over and over looping. So we're assuming that Graham at least is always getting closer to where he wants to go. So if Graham wanted to go to this dot right here, he would not go down first. Graham, you're smarter than that. There's only one way to get to this dot. If he wanted to get to this dot, would you agree there's only one way he could get to that dot? But if he wanted to get here, does it make sense he could go through this dot or through that one? There would be two ways. What about this dot? How many paths go to that dot if he's not stupid? Ooh, it's dangerous now, right? Because if you say the wrong answer, does that imply that I think you're no? Okay, it's one. The only pathway is straight there, right? And this one too, only one pathway to get there. The corner, only one pathway. These ones down here, also 1, 1, and 1. Right? If you live on, let's say you live on Ness and you're walking home from school. There's only one way you can get home without being redundant and taking a longer route. It's kind of boring. Your walk home's always the same. I live really close to the school. I have 3 different routes that I can take home. So Thursday and Friday, if I'm walking home, it's not exciting anymore. I've already walked this way every single time. But for Graham, walking to the library, he's got some options here. If we think about this dot right here, how many ways can he get to that dot? Well, let's count them. 1, 2, 3. Ooh, I guess I kind of gave away where I live. Anyways, there's 3 ways to that dot. And there's 3 paths to that dot. And now I want to see if you can see a pattern, because I'm going to give you 3 more numbers, and then I'm going to ask you to see if you can find the pattern to figure out the rest. To get to this dot, there's 4 ways. This dot is also 4 ways. This dot is 6 ways. So looking at your patterns, how many people think they know what's going to be here? Any guesses? And that same number is going to be over there. Five. Yes, you're correct. 5 there, 5 there. Maybe someone was using 1, 2, 3, 4, 5. Perfect. But now this dot right here. If I wanted to get to that dot from home, does it make sense that I can only get there this way or this way? If I came up, that would have meant I was backtracking. If I came from over here, that would have meant that I was backtracking. Those are the only 2 ways I can get to that dot. How many pathways do you think are to this dot? 10. Why? Well, if there's 6 here and 4 here, here I could get there in 10 ways, because I could either take any of those 6 routes or any of those 4 routes, put them together, I get 10. 10 there as well. What number is going to be here? 15. To get to this one? 20. 15. 35. 35. 70. Which isn't very hard to count or write it out. If you did 8 factorial over 4 factorial, 4 factorial, you'd have found that answers to be 70 as well. And so that's another way of counting the pathways. Now we're going to add a part B to this question. Well, maybe I won't add part B. Maybe I'll save part B for later. I'll save part B for later. Keep things simple right now. Okay, questions you can do for practice on this one. Try number 12.